Okay. So I just went ahead and opened up the Turnitin assignment so that you can turn your homework in on consumer choice. And it's due next Monday at 11:59. So you guys have the rest of the weekend if you haven't already, finished it. But if you were waiting on like this last question, we'll talk about it today, and then you should be able to complete the assignment probably already. I don't know how many people are still stuck, but this is kind of your chance to ask questions if you are, and then we're going to move on. So as I kind of get started, I will ask though, does anybody have any particular questions? And do me a favor and go ahead and put here in chat if you're here. Okay. Okay. So, okay, seeing no particular questions, and so Arslan, will you do me a favor?
Yeah.
Can you keep an eye on the chat for me, because I gotta clear up my screen.
Will
so
do.
if somebody, okay, thanks a lot. Okay. Okay. And so so in order to answer this particular question, let's see. Ruben, how are you doing this morning? Hi, Ruben.
Hi.
Hi.
Good. How are you?
Well, pretty good. I'm pretty good. So I'm gonna ask you, and let's see. How about Michael Barbie? You here? Oh, you're on the phone. Okay. So can you?
I'm here, Professor.
Can you see everything? Or are you to participate? Or since you're on the phone, I don't know if you're a little bit.
I can. Yeah, I have my laptop on. I just call in with my phone for.
Okay. Okay. Fine. Great. So when you see this question number 20 problem, how do you feel about it? Or do you have any particular like struggles, or the difficult part here is properly interpreting this phrase here: substitution effect on purchases of tacos. And but I don't want to throw words into your mouths, but so Ruben and Michael, are you okay with that, or you need a little bit of help?
I figure it's kind of like question 19, except the price of tacos is lower.
Well, yeah, and actually, no. I mean, it's not that the price of tacos is lower. So, I mean, in this example, this is one I just pulled off fresh from MicII, right? We have tacos going from $6 to $4. So it's the exact same, like we've been dealing with the whole assignment, the same prompt, and so this one, is based on the same premises as question 19 is, right? you have two goods and one of them has a price change. But then, we have to understand what the substitution effect is. And so I'll show you all, there are really two issues, and it just depends, when you pull a version off of a Minimization for either a homework assignment or for an exam. You can either get, there's a price change, but you could get a price increase or a price decrease. So I don't remember, maybe Michael, what you were talking about. I mean, I could be wrong because I don't remember our last one in question 19 that we did on Tuesday, if it was a price increase instead of a price decrease in the price of tacos. I don't remember, but that can happen. So you have to be kind of careful. Is that what you meant, Michael, or?
Yeah, the problem that we went over on Tuesday, the price of tacos changed to, or it increased.
It increased. Okay, well that's good because here it's decreasing. so that's a good point. And so there are different cases, and the cases have to be treated differently. So that's issue that's important. What about you, Ruben? Are you okay with this question?
Yeah, I think I'm okay.
Okay, so well, I'm going to go ahead and show really quickly for the uninitiated the two cases that we have to worry about. And again, if you all have been watching the YouTube videos dealing with consumer choice, then you've already seen this. So I'm just kind of going to give a quick summary. And so you have these two cases that you have to worry about. One is the price increase case, and the other one is the price decrease case. By the way, on this one, if you happen to occasionally, I don't know if it's like 1 out of every 50 times or something like that, Ignithium will pull up a version where there's no price change. And for exam purposes, I ask people if that happens to consider it an error and to use the substitute questions, just because the problem is sort of trivial if we don't have a price change in the change of the price of the good that we're considering. So okay, so initially, right, how do we illustrate this? And I could go ahead, hopefully you all know at this point in time that tacos is the good on our x-axis. And so I'll label it just to be careful. Okay. And so Michael, are you there?
Yes, I'm here.
Yeah. So as I'm getting started on this, did you watch the videos well enough so that you understand what the consumer choice problem illustration looks like for substitution and income effects?
Yeah, I have the graph in front of me.
Okay.
It seemed, yeah, I feel like it was explained well, but it's a new concept to me, so it's kind of hazy.
Yeah. Well, so what we do is we start out with, remember, we have this budget constraint, right? And I'm gonna try to do a good one here. And what I mean by a good one is one where I can, in the space that we have, because this illustration has a lot of detail. So, but there you can see my two budget constraints, right? And I'm not gonna put more labels. Can you see the budget constraints in orange there?
Yeah.
Okay. Now I'll let you do the price increase version. So if I was gonna draw another budget constraint where the price of tacos increased, what would it look like?
The slope would be steeper.
Yeah, good job. So it would look like this, because when the price of tacos goes up, you can purchase fewer tacos, right? And I'm gonna make it a pretty big price increase just so we have room. And Ruben, for the price decrease case, what should my new budget constraint look like?
The slope should be smaller. Right?
Yeah, it should be flatter, right? So
Yeah.
so you could purchase more tacos. So what I'm gonna do actually is I'm gonna kind of adjust this a little bit, again, just so I have more room for the illustration. So those are the two cases, right, for the budget constraints, where the purple one is the new budget constraint. So then the next part of this is we have to illustrate the consumer's optimal choice. And I've been thinking for a long time, based on the tools that we have available, how best to do this. So I'm gonna I don't know. Yeah, I don't know that would work really well. So I'll just have to try to hand draw it and do the best that I can. So okay. So here's going to be one indifference curve that's going to be tangent to the purple budget constraint. And here's the other one. And by the way, the reason why I'm drawing this carefully as I can with the tools I have available is this is usually the illustration, or at least one of them, that I ask you to do on the next exam. Okay. So you want to practice this and make sure that you have it handy. Okay. And that's fine. And I'll have our optimal consumption bundle in the orange case, the point of tangency there. And I'll also have the purple one. Okay. So hopefully one of the things that you see immediately is to even begin problem 20, you have to start by solving two consumer choice problems, right? So, and I'm going to call the one associated. Now, I get a little bit concerned about illustrating this carefully, but I'll put X1 star, okay, and oh, actually, this should be X1 star, and this one should be X2. So let me shrink everything. Okay. And then over here, it's X1 star and X2 star. Okay. So hopefully you can see that we have this, and we can refer to it as the total change in X, right? As a result of the price change. So I'm gonna call this the total change. And normally when we're in class, I would use this as a capital Greek letter delta. But here, I'm just going to use the lowercase d. And so the change is always where we end up minus where we started out. So it's going to be X2 star minus X1 star. That's the total change. And so, okay, at this point in time, Ruben and Michael, is there any question or any ambiguity about what's going on?
No.
No, nothing.
Okay, good. Well, so in terms of solving the problem itself, I think things are looking pretty good. Now, not necessarily for the illustration, because again, if you all have been watching the videos, there's this whole issue about decomposing the price change into a price change holding income constant and then a change in income. And we could talk about that in a minute, but that process of showing that a nominal price change can be decomposed into a price change holding income constant and then a change in income. That's the main substance of what we're doing here. But when we do that, that gives us another point on the original indifference curve, and that's what we solved for in question 19, that is XS. So I'm not going to go through that part of it, because again, we're just trying to focus on can we actually solve this problem. And so I'm just going to put XS here, and I'm going to note that XS will be some point in between these two. And I'll just put it there, and on the other side I'll put it here. Okay. All right. And so I'll make this in dark blue. And here we go. So XS is some point here. I'm trying to make it so it's not, it doesn't look like it's at the end of the budget constraint, because that's not true. And so over here, it's probably a little bit clearer at some point there on the axes, but I don't want to put it exactly in there just because I don't want it to clutter the diagram too much. Okay, so I'm assuming you all can see that just fine. Michael and Ruben, you know what I'm talking about, right?
Yeah, it's a point on the indifference.
Yeah, no, well, it's not yet. I mean, I'm just pointing that XS is, it's some value here on the x-axis that's in between x1 star and x2 star. So pretty simple. And okay, and so then what I'm gonna do is I'm gonna draw here actually, and again, this is just for purposes of illustration. I'm gonna draw this pink line here. And the pink line itself has no economic significance. It's just there to mark the division between that distance x1 star and x2 star. And so the substitution effect is going to be, let's see, I gotta pick good colors. I'll do this one. So the substitution effect is going to be this distance here. And I should be a little bit clearer that, and again, if you go through the videos carefully, you'll see that this is the impact of the substitution effect on the price of tacos, as opposed to the substitution effect itself. The substitution effect itself is actually a derivative. It's a dxs d p holding, this is the change in price. So the distance between what we are calling the impact on tacos, right? We're doing like the first part of the denominator. We're not doing divided by the price change. But again, if you go through the videos, it's actually a derivative, and we're just doing the numerator of that derivative. And then the income effect is this other portion, and I suppose I'll do it in yellow, which is the distance between XS and X2. And then you add them together and you have the substitution income effect add up to the total effect. Again, that's all in the videos, but these are the two cases. And I don't think that in all of the videos, I ever clearly illustrate the two cases like I'm doing here. But so I'll ask you then, if you have any questions, Ruben or Michael, do you all think you can solve the problem now? Ruben, Michael?
No, I don't have any questions.
Okay. And Michael?
Am I confident in solving the problem? I'm not confident, but
Well,
I'm sure I'll be able to figure it out later.
Can you put a little bit of meat on the bone and tell me, like, based on the illustration you see here and what I've described, which part of it? I mean, if you look at it, you're like, I don't know where I'm going to get. You know where you're going to get X1 star, right? And you know where you're going to get X2 star, I hope, because those are just, and then the number 19 was XS. And so the substitution and income effect impacts on the price of tacos are just these distances here. They're just the difference between, right, X1 and XS. And you can see for the price increase and the price decrease, right, they flip sides, right? So if you can find X1
Okay,
star,
never mind. Yeah,
X2 star, and XS, then, it's just a matter of, taking the differences between those three numbers and you can solve it. So, okay, let's see who all else. Okay. So Devara Arslan, how are you doing?
Doing good.
Okay.
Hi. Good.
You okay? And what about you, Emilio? And Joshua?
Yeah, I'm doing good.
Okay, Joshua?
I'm doing good.
Okay. So I don't know if you all need to, but you might want to, like, take a little screenshot of this really quickly. So I'll give you, I don't know how long you need, 10 seconds. And then we'll go back to the question. Okay. So Devara, Arslan, Joshua, Emilio, and everybody else, and Ruben and Michael. I'm going to ask you all about your answer to this question. You have all the information before you. So go ahead and work on it, and then we'll come back. It's going to take probably a few minutes for you to do it. So we'll come back at 8:30, and then we'll walk through it. Okay, just the answer part. Anybody have any questions? Okay. All right, see you in 10 minutes.
Actually, Professor, I have a quick question.
Yeah, Arslan, go ahead.
So based off number 19, we denoted X0 and Y0 as like how much tacos and tequilas we purchased at the original prices.
Yeah. Oh, but I
X1?
switched it to X1 and X2.
Just
Yeah.
here, yeah.
Yeah, and yeah, that's fine. I like to use X1 and X2, and sometimes like, initially I'll use like X0, but I think anyway, for this particular version of the problem, or what the illustration, I want to make sure I get like, the dynamic sequence like at time 1 and time 2, and sometimes if I start at 0, I think it's more confusing for students. So sorry if I threw you off. I was trying to be more clear instead of less clear, but those subscripts are just merely, labels. You could call them A and B if you wanted to, and that would be fine.
Sure, thank you. Yeah, I mean, it's easy knowing that. I just wasn't like sure if we were looking for something else. Thank you.
No, sure. And do me one favor, Arson, when we do come back in 10 minutes, remind me to hit the record button again.
Will do.
Okay, I'm gonna pause the recording. Okay, thank you. Devara?
I'm not done yet.
Okay, are you, well, let's see, Arslan, are you done?
Almost, just need a minute.
Okay. What about Michael, Barbie, Ruben? How are you guys doing?
I'm not.
Okay. What about you, Ruben? How are you doing?
Yeah, I'm done.
Okay, Ruben's done. Arsenal, what about you, Joshua? Done. Emilio?
I just need a little minute.
Okay. Okay, so, well, let's kind of walk through this a little bit slowly. So we're gonna need an X1 star, right? And we need I'll just put it in the middle of XS. And we're gonna need our X2 star. Spread this out just a little bit. Okay. So these are our 3 values that we need to compare in order to answer the problem. Okay. So, we'll start out with Michael and Devara. So Devara, do you have our X1 star value?
I got 22.26.
And so you have 22.26. And I'm not saying it's right or wrong, I'm just noting it down. and what about you, Emilio? Do you agree with Devara for X1 star?
Yeah, I got the same thing.
Okay, is there anybody that disagrees? Because I could go back and check, but I'm just, gonna go off of what you guys tell me. Because if we don't get it right, obviously we'll get wrong answers. So, anybody disagree? No.
I got a different answer.
Oh, Arson got a different answer. Okay, okay. Well, let me see if I agree. So this would be the amount of tacos at the initial price of tacos. And actually, it looks like to me this problem is really nice because it's going to be, the numbers are straightforward. So yeah, I think I got a different number too. So, Emilio, you said you got the same answer as Devara. Do you want to defend the answer? Tell me how you did it.
Yeah, so I just plugged in the numbers that were on there already. I think I did a little miscalculation though, like now that I'm looking at it.
Okay, do you want to revise your calculation? See, gotta be, hopefully you weren't just agreeing with Devara because Devara said it. If you did that, you know, remember that academics is never about democracy. It doesn't matter how many people vote for a certain answer. If it's not right, it's still not right. So, okay. Well, without running through all the calculations, so Devara, what about you? Do you want to tell us anything about? So you must have had like the marginal rate of substitution is equal to the price ratio for one of your equations, right, Devara?
Yeah.
Yeah, and then you substituted that into the budget constraint equation,
Mhm.
and this is what you got out. You must have made a calculation error.
Yeah, I'm gonna double check right now.
Okay. Mm.
Excuse me,
So go ahead.
just to make sure my equations are also correct, one of them should be, let's see. Well, do you mind if I say, I don't know if that you don't want us to say the answer or something?
Well, I can no, you know,
I just want to make on the
we
right.
we gotta kind of wrap this up because we went through it in great detail. So I'll do the, you know, the first equation is the alpha y, and I'm not gonna, if this is confusing to you at all, go back and watch the other video, because, you know, I'm not gonna put in the extra parentheses, um, and all the subscripts and everything like that. But that's your first equation. That's the tangency condition, right? And then the other one is your income is equal to px times x plus py times y. So who was talking? Was that asked if they could?
Yeah, I just wanted to make sure I was on the right track. Yeah, that was all I.
Did you do this part?
Yeah, yeah.
Okay. So which of the equations did you want to check? I can run through it with you really quickly.
That's what I wanted to make sure I had the right idea in general, making sure I was, you know.
Yeah. Yeah. So these are your two equations that you have to solve. And Devara, you know.
Yeah, I made a mistake. It's 6.23.
Okay. And what about you, Emilio? Do you agree with her new calculation?
Yeah, I did the calculation again. I got 6.20. That's still
Okay.
guessing, I think, yeah.
Okay. So 6.23. Okay, Arslan, are you in agreement now?
Yeah, that's the answer I got.
Okay. So and then I'll ask Ruben and Michael Barbie. What did you guys get for X2 star? Do you want to tell me, Michael? You can go first.
I haven't gotten that far yet.
Okay.
I got 9.35.
Okay, so you have 9.35.
Yeah.
Okay. Well, okay, yeah. And so you have, let me put it here, 9.35. Okay. So, and what about you, Joshua? What did you get for X2 star?
Let me try to find it here in my work.
Oh, okay, so you don't have it handy.
I don't have it very organized. I got the final answer, but organization isn't a strong point.
Yeah, well, you want to work on that for your documentation. Go through these and lay them out, you know, as clearly as possible. What about you, Arslan? You said you were done.
Yeah, you
9.3.
wanted XS?
Oh, wait, that's going to be X2 star.
X2 star, I got 9.35. Yeah.
Okay, so we had 2 verifications on that. Yeah, and then the one that's the more challenging one is the one that's here in the middle, right? Which is XS. And so why don't you go ahead and give me your value for XS, Arslan?
I got 8.6217.
Yeah, okay. So 8 point, I'm gonna say, I just looked on Ignithium and it may be a rounding issue, but it shouldn't affect us again when these numbers are big enough, but I'm still gonna put 8.63. That's what's on Ignithium. Okay. So I don't know if you have any concerns about that, Arslan, but if you do, we can.
Close enough. I'm going to assume it's just a rounding issue.
Yeah, I think that's right, and I wouldn't be too worried about it. Okay, so now the impact of the substitution effect on the price of tacos, right, then should just be, I'll use that difference there, right? And the way that we want to think about this is that it's going to be, and I'll say the sub effect, and it's going to be, we're starting at our initial quantity of tacos, and we're going to XS. So the change is XS minus X1 star. And just do it this way and like that. Okay. And so what did you get, Arslan?
2.4.
Okay, so I'll say 2.4. And you'll notice that here, right, it ends up being a positive value. And this is kind of, sometimes I'll point out to you something that's in one of the videos, and I go through a lot of effort to kind of correct the perception, because what we say is that the substitution effect is always negative. And remember, what we're actually calculating here is the impact of the substitution effect on the quantity of tacos purchased. So we're actually answering the question number 20 on Ignithium, as opposed to calculating the substitution effect itself. So I'm gonna clarify a little bit and just say impact on X. Okay, that's what we're actually calculating. The substitution effect is always negative. And remember, as I said before, the true substitution effect is this value we just calculated, I'll call it dxs, divided by the change in the price, right? And here we've got a price decrease, right? And so our dp is actually going to be P2 minus P1 for tacos, right? And in that case, we're going from, remember, it's where we end up 4 minus from where we started out. So the price change is negative. And so you'll be able to see pretty clearly that the ratio, right, of a positive to a negative gives you a negative value. Okay, and that's what we mean when we say the price increase is always, or excuse me, the substitution effect is always negative. And so in the case that we had a price increase instead of a price decrease, then we would have DP would be a positive number, and this XS minus X1 star would actually be a negative value. So that's the only point that I wanted to make. Does anybody have any questions about that?
Benjamin has a question for the equation to find excess.
Okay, Benjamin, go ahead.
Or I guess he's just answering.
I'm pretty confident on how to solve or figure out X1 star and X2 star. I just got a little confused on where we got 8.63 from, and I just wonder if you could help me out with that.
Well, okay, you have to tell me, did you watch the video from Tuesday?
Yes, I did, sir.
Okay, and then you know that XS is a result of a different set of simultaneous equations. Do you remember what those are?
No, that's why I can't solve for XS.
Well, you got to go back and watch that video because we spent like the whole class doing it. But I will tell you really quickly, right? So in that case, we're going to have these same two, and I'll try to illustrate it for you. So we have these simultaneous equations, right?
It's okay, Professor. I'll just go back and watch.
Well, I want to see if I can help you out a little bit. Because I mean, this is the whole ball game right here. So you see these two simultaneous equations that I highlighted in orange? Ben? Yeah, are you there? Oh, did I lose you? Ben? Oh, can you hear me, Arslan?
Yeah.
Okay. I don't know, I lost Ben. Okay. So, let's see. Chat. Oh, okay. So, Ben, can you see what Arslan put in the chat? Is Ben still here? Oh, I think we lost Ben. Okay. Well, anyway, yeah, if everybody looks in the chat, these are the two different equations that we need to find XS, if anybody has any questions about that. So, okay. Now, the one thing that we haven't finished up yet is, and this is the income effects. Again, impact on tacos, on taco purchases. Okay, so on the purchase of X. And again, it's going to be like we're starting out at XS, but then we're moving to X2. So it's going to be X2 star minus XS. And I'm putting it down here because even though it doesn't show up on the Ignifium homework, this is a question that I sometimes ask on the exam. Okay, so it's a very simple calculation. And again, if we were going to actually calculate the income effect itself, in that case, we would have this income effects impact on the purchase of tacos, which I'll just call DXI for income, right? But it would be divided by the change in income, okay? And it turns out, though it's kind of difficult, it's not really difficult, it's just you have to be sort of creative when you think about this problem, okay? And I talk about it a little bit, but when you illustrate an income change for a budget constraint, and I'll show you all over here really quickly, right? Remember that an income change, and the reason why I'm telling you this is because it's, you know, these are kind of like guideposts for how to do the calculation. So since you were chatting, Arslan, I'll talk to you for a minute. So you see, Arslan, how that is an illustration of just an income change holding the prices constant, because the price ratio ends up being the slope of the budget constraint. And since we don't change prices, we're just changing income, then it's just a parallel shift of the budget. Do you see what I mean?
Yeah.
So when you're doing this to calculate the, and we didn't illustrate it, but you'd have to go back to some of the other videos to see the illustration clearly, then we end up with two parallel lines that represent the income portion of what we call this income and substitution effect decomposition. And because of those equations that you used to calculate XS, and XS, remember, is the point that we use to construct the decomposition, right? So what you can do is you can use the slope value and the point XS in order to construct a version of the shifted budget constraint in point slope form of a linear equation. Okay, so do you know what I mean when I say point slope form?
Yeah.
Right, so point slope form is, so once you have XS, then using point slope form, remember point slope form is where you end up taking this ratio, and I'll just write it generally in terms of equations, but it's y minus some specific point y0 divided by x minus x0 is equal to the slope of the equation, right? And here, your y0 x0 point is XS, okay? And then you have the slope from that system of equations that you were given, which is basically, you know, the new prices, right? And then you can use this form of the equation in order to turn it back into a slope intercept form for the new budget line. And remember, the budget line ends up being a certain amount of income if you write it in, general linear equation form, which is our px times x minus py times y. And if you do that, then you can get this new implicit level of income associated with the decomposition. Does that make sense, Arslan?
I'm following so far.
Yeah. So then if we go back and we calculate this income effect, our di down here, if we wanted to actually calculate the income effect as dxi over di, is going to be that change in income from the original level of income that we were using, which in this case is 187, to that implicit level of income associated with the decomposition. So if there's somebody that's interested in playing around with that, then you're welcome to come to office hours and we could play with it. It's not something that you would be asked on an exam. I've never asked anybody like that on an exam. But if you're sort of curious and you're like, oh, we never actually calculate the true income effect. In the case of the substitution effect, calculating the true substitution effect is pretty straightforward in the sense that you have all the information there available on Ignithium to calculate this ratio. But for the true income effect, you got to work a little bit harder outside of the scope of the problems on Ignithium in order to actually calculate the true income effect. But the important point is, so the income effect can either be, okay, and I'll kind of put a question mark here, a couple question marks. It could be less than 0, or it could be greater than 0, okay? And so this gets back to our original point. So have you followed so far what I said? Arslan, are you good?
Followed it so far. I'll probably pop into office hours just to learn more.
Okay, so but the point about this is the income effect tells us whether or not the good is inferior. It has a negative income effect, which means, again, other things being equal, if you change the income by, let's say, giving the person more income, if it's a negative income effect, then that means that the numerator would be negative. So you give them more income, so DI is positive, then they purchase less of the good, right? Or it could be a normal good, in which case the change in their purchases, as you give them more income, they increase. If you decrease their income, they purchase less of the good. So this is all about distinguishing between normal or inferior goods. Okay, so that part's clear, right, Arslan?
Yeah, that is clear.
Okay, but notice, right, that what can happen is, so for example, you always have a negative substitution effect, which means that the change in the purchases of X are going to be opposite the direction of the price change. And it turns out that, like for our example, where we had a decrease in the price of X, right? So we have this, I'm trying to highlight it. We have this decrease in the price of X, okay. It doesn't really want to let me highlight this. Okay. So we're going to have an increase in the purchases of X due to the substitution effect, right? But it also turns out, and if you think about this, it'll kind of make sense as you go through the decomposition. So I'll just say it pretty quickly. But if you decrease the price of X, and this is again on the videos in greater detail that are available online. If you decrease the price of some good, and this is what we're talking about at the beginning, like if I decrease the price of your housing, we free up a lot of income. So implicitly, we've increased your ability to purchase all goods because your housing costs, a big part of your budget, has been freed up to purchase other things. So we're expanding your affordable set, which means we're actually increasing your implicit income, okay? And if we increase your implicit income and the good happens to be an inferior good, right? So, and I'm gonna try to illustrate this. So I'm just talking about this if we have this case of inferior goods. If we have the case that it's an inferior good, then when we increase your income, you purchase less, right, Arslan?
Yeah.
Yeah. So what that means is, in the case of inferior goods, the income effect, and a lot of people say it this way, the income effect works against the substitution effect. The substitution effect encourages you to purchase more of the good, right? Because the price has gone down. But the income effect encourages you to purchase less of the good because you've increased income by decreasing the price. And if the good's inferior, then you want to purchase less of it, right? So it can be the case, and there's, I think, a good illustration of this in your book, though I don't remember the page, that the income effect can overwhelm the substitution effect when they're working in opposite directions. And if that happens, it could be the case that even though the price has gone down, that due to the income effect overwhelming the substitution effect, the purchases of the good can actually fall. And if you think about what I just said, I said the price goes down and purchases fall, which means if we just reversed it, you can get a situation with an inferior good when, if the price increases, that the consumer actually purchases more. So that is what gives us the upward sloping demand curve that we were concerned about.
Do you have any examples of a like hypothetical good that would illustrate this?
Well, yeah. So I do, and I just want to make sure that we understand one other thing, and that is when it is the case that the good is inferior to the extent that the income effect overwhelms the substitution effect, that's what it means to have a Giffen good. So we had this particular language we were using of, and I'll just put it here, maybe in pink, Giffen goods. They're inferior such that the income effect, and I'll just put like this, exceeds the substitution effect. And Giffen goods can generate upward sloping demand. Okay. And so I'll answer your question sort of in reality. And it's kind of difficult to think of good cases, and obviously depends upon the preferences of the consumers. But it's important to point out that what we've done is we've shown that even though consumers are rational and they have utility function representations for their preferences, because remember, if you're rational, then we can find a utility function that represents your preferences for goods. Even rational consumers can have upward sloping demand curves in particular circumstances. And that's what this whole thing illustrates, and how it is that some people won Nobel Prizes. So to get to kind of the reality behind this, there aren't very many good examples of Giffen goods. The one that is used historically is the potato famine data from the Irish potato famine. I don't know if you've ever heard about the Irish potato famine, and maybe it's a good idea. I mean, no, coincidentally, we're talking about a day after our national Irish holiday. So Arslan, are you familiar with the Irish potato famine?
Vaguely.
Okay, so in the Irish potato famine, you know, the potato crops failed. They got blighted, which means basically a bunch of mold. I don't know if you've ever grown a potato, or the potatoes grow in the ground, but if conditions are kind of right, there's enough moisture in the soil, you can get this fungus, and it'll kill a bunch of the potatoes, make them inedible. So this is our St. Patrick's Day, post St. Patrick's Day history lesson. Did this happen? So it turns out that in Ireland at the time, that you might think that folks would, maybe their diet would primarily consist of bread or something like that. It might grow wheat, but that's not the case. It turns out that potatoes are very calorie dense, and if you want to feed a lot of people, potatoes are just about better than any other source of carbohydrate nutrition. So the average person at the beginning of the potato famine would basically divide their consumption between three goods that they would eat. They would eat potatoes, and they would eat cheese, and they would eat mutton, which is sheep. And obviously, what we're going to see is that when the potato crop is blighted, there are many fewer potatoes, and the price of potatoes is going to go up. So that makes sense, right, Arslan?
Yeah.
Yeah. So, but something that they noticed that was weird is that even though consumers preferred to eat mutton and cheese, that mutton and cheese were a relatively small part of their diet prior to the beginning of the potato famine, because they were much more expensive. And so, the way it would work is kind of like, I don't know if you and your family, do you have spaghetti, or I don't know if you guys, what's your typical family meal look like, Arslan?
My mom makes a lot of spaghetti. It's the easiest thing.
Yeah. Okay. So spaghetti, and notice, right, that spaghetti is made from wheat flour, but that's your big source of carbohydrate. And then normally some people would just put pasta sauce on it, but without any meat. But you're eating a relatively small amount of meat. So imagine that's kind of like what the Irish were doing at the time. They're eating a bunch of potatoes and a little bit of mutton and a little bit of cheese. Now, if the price of potatoes goes up, and they try to switch into getting additional calories with eating more mutton and cheese, they just can't purchase enough of it that they're not going to basically starve, right? So what they ended up doing is, as the price of potatoes went up, they began to rely almost exclusively on potatoes, right? So they would purchase, less mutton and less cheese and take that money and go purchase potatoes, because they really needed, again, we're talking about life and death sustenance, right? They're trying to purchase enough potatoes to survive. So in the Irish potato famine, when the price of potatoes went up, they actually ended up purchasing the same amount or more potatoes than they did before the potato famine. So, and that's actually kind of what's, inspired this whole analysis that we're looking at, is that prior to the Irish potato famine, people might have said, oh, well, it looks like we have upward sloping, demand curves for this little piece of data or that little piece of data. And economists would kind of, wag their finger and say, well, we don't think you collected the data very well. The data is not very comprehensive. We don't have, enough data on consumption, basically kind of just waving their hands and saying they think it's a mistake. But the Irish potato famine data was really clear and presented an unmistakable case of a situation where the price of a particular good, in this case potatoes, went up, and consumers actually purchased more of the good. So and it didn't have anything to do with any of the other things that we talked about. Not that, I mean, these are much more modern concepts, but when we talk about network effects and social influences of luxury goods on people's behavior, that's obviously has nothing to do with potatoes, right? This is a rational response of people who are trying to survive. So that's the best example that I can give you that's real world and historically well documented. Are you convinced, or
that helps? Thank you. Yeah, I just like, but it does seem like this is a pretty extreme case as far as Giffen goods even existing, right?
Yeah,
Or
no, it's very rare, and that's, I think, part of the reason why folks have spent some time trying to explain other cases where it seems like there's something similar going on. Like, again, social influences on people's preferences for luxury goods. It's obviously, that's not really, Giffen good territory. Nobody would argue that luxury goods are inferior. In fact, right, people, as their income goes down, they purchase many fewer luxury goods, and you normally only purchase luxury goods, the Gucci handbags, when your income goes up, right, and way up. Those sorts of phenomenon maybe give you a little bit of an insight into the way that, like all sciences, economics progresses and develops ways to expand its theory to account for these real world phenomena. But yeah, okay, so I won't spend any more time on this. You all should have plenty of information between all the videos and the illustrations in order to complete your homework. And just so you know, I imagine our next exam will be relatively quick, which means that, and we have to move on to new material. So I want to, and I know that we have spring break coming up. So probably the week that we get back from spring break, and I will make sure that I post this on Blackboard, is when we would have our next exam over this material. So, okay. Does anybody have any questions about that? Okay.
I have a question about the previous exam.
Okay, well, just hold on because we have like another half hour, and I wanna talk about one other thing first, and I'll save 5 minutes for you. Okay.
Thank you.
Sure. So okay, we kind of learned last time that this basically it's a linear constraint with these Cobb-Douglas type functions can be used not just to represent consumer preferences, but can also be used to represent production functions. And so let's go ahead, and I'm going to Ignithium now. And so our next homework assignment, and we're going to kind of go through these pretty rapidly because, again, we want to get down to at least the Cornell stuff before the end of the semester. And so here you'll see, and this homework is pretty short. They have cost curves, and undoubtedly you all are familiar with cost curves. You know, the probably, you know, pivotal concept that you might want to review, and again, we have videos and stuff like that, but is the concept of marginal cost. And I'll speak in greater detail if necessary about questions 11 and question 12. They're a little bit more complex than the other ones, but this is just walking you back through things that you should already be familiar with from principles. And instead of just using illustrations, we're using these functions to define the cost curves, right? So let's go back here. But there's kind of a bigger question here, which is, okay, where do cost curves actually come from? And you know, the thing that we're not going to go ahead and you know, spend time solving these types of problems, not because they're not important, but you know, this class is more about developing techniques that you might use in other upper division classes, and to make sure you're familiar with them. So there's this other problem, which is, it can be illustrated using these types of functions and the techniques. It's called the firm's, I want to use a different color. Firm's cost minimization problem. Okay. And so for the firm's cost minimization problem, it's exactly the same techniques that we've been using, right? But rather, the problem is stated a little bit differently, okay? Remember, for the consumer choice problem, we had, the consumer choice problem is to maximize utility, okay, subject to a budget. And that's what we've been doing, is we've been maximizing. We have this Cobb-Douglas utility function where, you know, we say U is equal to some function. In this case, it's a Cobb-Douglas representation, but generally some function of these two goods, X, I'll just say X1 and X2. We were calling them X and Y before, but you can imagine that, you know, again, you can extend this analysis to have any number like 3, 4, 5, and then right? It's easier to just use subscripts to indicate the different goods. And the budget then is this, right? Income is equal to, when we could write P x1 times x1 plus P x2 times x2, and so on, right? If we had multiple goods, we just keep adding, right? Additional terms for, notice that the left side here is income and the right side is expenditure. We talked about that before, but I just want to be a little bit clear in case there's any confusion. Okay, now for the firm's cost minimization problem, the way that it works is firms are going to minimize cost, okay, and they're minimizing the cost of a production target that they have, okay, and so they're minimizing the cost. So now, instead of saying the budget comes first, we're going to say that the firm's cost, right, which is their expenditure on different, so I'll say C, right, their expenditure on different inputs to produce is equal to, again, just the price of the inputs times the number of inputs they use. So the way we would normally do that is we call, I mean, this is just, you know, a matter of, you know, what symbols you want to use, but it's typically, you know, it's common to use the word wage to refer to the price of an input, whether it's labor or materials or something else. Sometimes you'll see that they'll use the word rent to refer to expenditures on capital and equipment, or you know, real estate. But generally, input prices are wages. So wage of 1 times the quantity of input 1 that you use, that's your expenditure on input 1, and the wage of input 2 times the quantity of input 2 you use. And the two, you know, typical inputs that we talk about just in broad categories are capital and labor. So you might note that on the other videos, I use K and L for the inputs, and I'll use a capital K and a capital L just so I can get the L to not look like a 1. Okay. But so you're going to minimize your cost subject to, right? So I'll put subject to, which we abbreviate as ST, subject to a production target. Okay. So when we're talking about production target, we normally have some level of output, and the symbol we typically use for output is Y. So Y is equal to some production function, and I'm going to say a function of capital and labor. So it turns out, again, this could be a Cobb-Douglas production function, and we showed you last time, we could use this technology parameter if we wanted to. And then it's K raised to the alpha times L raised to the beta power, where alpha and beta sum to 1. That's our case, okay? But so how we do this is I'll go ahead and I'll put labor on the horizontal axis and capital on the vertical axis, and Then we can imagine different levels of cost, right? And instead of getting a budget constraint, we get this, what we call an ISO cost line, right? So I don't know if let's see, who do we have? Okay, how about Andres? Are you here?
Yeah, I'm here.
Okay, so do you see, Andres, how this is this is actually the firm's expenditure on its materials, which we're calling its cost.
Yeah.
And by the way, in terms of language, there's a big subtlety here, okay? And the subtlety is, this is often called the firm's cost equation, okay?
Yeah.
And I want to go ahead and write that here, and I'll put it in pink, you know, the cost equation. And this is what a lot of students get hung up on. And this is not equal to, so I'm putting these exclamation points, is not equal to the firm's cost function, okay? So this first one, the expenditure on inputs, is what we call the cost equation, right? And what we want to do is talk about the relationship between the cost equation and this cost minimization problem and the cost function. So now we can imagine different levels of expenditure on the inputs, right, Andres?
Yeah.
And those would just give us different, they look like, again, like budget lines, but they have a different interpretation here. These are what we would call the firm's ISO cost lines, okay? And ISO cost, ISO is Latin for same, so same cost, right? So all of the points on you know, this on any of these lines, like if I take these two orange points here, they represent two different levels of capital and labor that require the same amount of expenditure from the firm, right? And if I do two other ones, let's do these two red ones. The two red dots are, again, they're on the same ISO cost line. It's like for the consumer choice problem, where consumers had these different bundles they could choose from that would cost the same, right? So these are different levels of capital and labor that cost the same. So they lie on the same ISO cost line. For consumers, they lie on the same budget constraint. Do you see what I mean?
Yeah.
Andres? Okay. So now this is kind of the tricky part next, and that is that if we solve this, we're going to get a system of equations just like the one that we had in the consumer utility maximization problem, except for the tangency condition. We said it was the marginal rate of substitution, remember, is equal to the price ratio. Well, here it's going to be, remember, the marginal rate of substitution is equal to the slope of the indifference curve, right? So we're going to have this other related concept, which is the marginal rate of technical substitution is equal to the price ratio of the inputs. So hopefully you're seeing a parallel here. That's going to be one of our equations. And then the other one is simply going to be our particular output target, because that's our constraint, is that we have a certain amount that we want to produce, right? So I'm going to actually go up here and I'll modify this a little bit, and I'll call it Y with a little hat. That's our production target. Okay. So I'll say Y hat is production target. Okay. And so then our other equation, it's going to be analogous to what we did with the income and substitution effect decomposition, because remember there we had a tangency condition, and then we had this non-linear equation, which was a targeted level of utility. So here we're going to use for our second equation that our production target is equal to our production function at our particular level of K and L that we're using. So those are the two equations that we're going to use. And what we're going to find is, again, we're going to, now this is going to be a little bit, hopefully more interesting in just a second. So I'm going to go ahead and try to move this. It's not letting me just move it. There we go. And I'll get rid of these other ones. So we're going to have, since it's Cobb-Douglas, a particular production target level, and I'll illustrate this in orange. And it's going to give us something like an indifference curve. Okay. But again, what this is going to tell us is it's going to tell us all of the combinations of capital and labor that can give us the same amount of output, right? And then if you think about what's going on, before in the consumer choice problem, we had a budget constraint and we were basically switching between indifference curves to find the indifference curve that was tangent. But here, what's going on is we're stuck on a particular contour line, the Y hat contour line. And that particular contour line that we're stuck on, they're called isoquants, okay? And again, this is in your book, and so I won't spend too much time on it, but we have, in this context, we have isocost lines and we have isoquants. Isoquant means the same quantity of output. So again, all of the input combinations that fall on this curve produce the same level of output. And then what the firm is doing is it's actually managing its costs, right, to try to minimize the cost of production. And that happens at a point of tangency. So Andres, do you see how I'm moving this isocost line, or I want to call it a budget line because that's what it looks like. And it's, like I said, that's the analogy. But you see here, Andres, if I have the isocost line away from the point of tangency, there are these two input combinations that cross the isoquant and the isocost. They can produce Y hat level of output, but at this higher cost than necessary. Do you see what I mean?
Yeah, I see.
Okay, Arslan, what about you? How do you feel about this?
Yeah, I'm following you.
Yeah, and so thank you. And so then our optimal solution is this input combination that gets our ISO cost, right, as close as possible to the origin. Okay. In the context of the consumer choice problem, we had a fixed budget, and you know what we were doing is we were taking, let's see, is it gonna, oh no, it's two pieces, so it's not going to let me move it. But in the I'll try to do one really quickly. So I'm gonna draw another, let's make it purple, another isoquant. Oh, that's not gonna work. Okay, but it's one piece. So again, this is kind of like an indifference curve, but in this context, it's related to production. Okay, so in the consumer choice problem, what we were doing is we were moving our indifference curves around to get the highest level of utility, and the highest level of utility corresponded to that level. Remember, levels of utility go up as you consume more of both goods. So that indifference curve for the consumer that was as far out away from the origin as possible until, again, we hit that boundary of what was affordable, and then we had a tangency condition. So the whole process is very similar, but it's just, instead of moving the indifference curve as far out as possible to get the most utility, we're which is like the peak of our mountain now, we're moving down the mountain as far as possible to minimize our cost of production. So, okay, to finish this up, so you can imagine, just like we had our price expansion path, right? You can imagine as the target for production, and I'll draw again another illustration. Okay, I'll make this one pink. Okay, so again, each of these isoquants represents a particular level of production. So let's just think about the pink one, right, as being any particular level of production. As we use more inputs, we should get more output. So as I move the isoquant out, it corresponds to higher and higher levels of production, right? But for each particular level of production, there's going to be a input combination that minimizes the cost of producing that particular level of output, right? Well, as we produce more and more output, our input combinations are going to change. What's optimal is going to change. And that sequence of, and I'll just draw another example here, just get two in the sequence, where we have another ISO cost line and another tangency, again at a different level of output. Let me take this and move it over here. So this one, let's call it level of output, and I'll put it in pink. Y hat, right, for even more level of output. So this is going to be associated with a different input combination. Obviously, we know we have to use more inputs to produce more output, but while still minimizing costs. But it might be the case that the mixture of capital and labor changes as we increase our production, right? So, and I'll just grab this arrow and move it around here to show this expansion path that represents the sequence of optimal combinations of capital and labor as we increase our production, okay? Each one corresponding to a certain level of cost that is the minimum possible level of cost for producing that particular level of output. So, okay, so I'm almost all done, Arslan. Do you see what I'm talking about? That input combination with this amount of labor and this amount of capital minimizes the cost of producing this level of output. That makes sense? And for this level of output, this point represents the minimum amount, well, or the optimal amount of labor and capital for minimizing the cost of producing that level. So remember, at the end of our utility maximization problem, we came up with, okay, well, the consumer can achieve this level of utility, which was our putting X star and Y star back into our utility function. Do you remember that?
Yeah.
Arslan? Well, so we can do the same thing here. Is we can define this C star, which is the optimal amount of capital and labor. So notice that this is our, let me highlight this. This is our cost equation, but it's our cost equation, the cost equation with the optimal combinations of capital and labor. So I'll have W1 times K star plus W2. And yeah, anyway, times L star. So it's like, you know, the maximum utility you can achieve, but instead it's the minimum cost you can achieve for producing a particular level of output. And this, that is our firm's cost function. Okay, basically it's an expansion path in the way that the demand curve was related to the expansion path in the consumer optimization problem. So when you see the cost functions that you guys have been seeing, and you'll see on your homework in Ignithium, the next homework we're going to be doing, those are actually you know, as the result of the firm's cost minimization problem. And that makes them different than this kind of simple cost equation representation. And if you think about it, it makes sense, right? Like Tesla, if they're building one car, it's going to be very labor intensive. They use very few machines. That's a small amount of capital. They're going to produce 1 million cars. Then it's going to be highly automated, right? And why are they switching from labor intensive to capital intensive production? Well, it's because the capital intensive production makes more sense from a cost point of view when you're going to produce a large number of the goods, right? A large number of cars. Okay. Everybody good? Okay.
Yeah, a quick comment, I guess, or question.
Yeah, I just want to say one other thing, and that is that
Okay.
I know you guys are finishing up your consumer choice homework, but please start working on the cost homework, because again, we want to kind of move through to the next material. I don't know if I would have the cost homework like due like next Thursday or the end of the week before you guys go on spring break, but I would have it due pretty quickly. And I don't want you guys to get, I know you're going to be studying for other things and whatever, but get started on the cost stuff. It's pretty simple, but if you don't, it'll just delay us. Okay, go ahead, Arson.
Yeah, just to kind of like sum up and generalize, you're saying that to minimize cost, we need to find like the optimal usage of labor and capital.
Yeah, the optimal combination of
would
inputs.
you call that the most efficient combination?
Well, okay. Yeah. So if you unpack the word efficiency in economics, it means a lot of different things, but it is closely related to the concept of productive efficiency or efficiency in production. Yeah. So it's, you could call it an efficient combination, and probably not too many people would stare at you in a funny way, but it would be an unconventional use of the language. Right?
Got it. So optimization doesn't necessarily mean efficiency, but they're kind of similar.
Yeah, they are similar. And I don't know if you go back over the really like early lectures, but general economic efficiency has the two components. It has allocative efficiency, which means everybody that's getting a good is getting the good because they value it more than anybody else. That's efficiency on the consumption side, right? Goods don't go to people who don't value them highly. If you don't care about diamond rings, it makes no sense for society to give you a diamond ring, right?
Right.
But on the productive efficiency, it's allocative efficiency and productive efficiency. The productive efficiency is about, at a social level, minimizing the overall cost to society. So the only thing that is a little bit not one-to-one between optimization and efficiency in the way that we're talking about it right here is this is one firm. So it could be that this firm is minimizing their costs, right? And picking their optimal input combinations, but they may not be the least
to society as a whole.
Yeah, they may not be the least cost firm for producing the good that is being supplied by their business. So, it's like, you've got GM and you've got Ford and you've got Tesla, and all these people are producing cars. Let's just assume for a minute that they're all producing exactly the same car, a truck or something like that. It might be that for particular reasons that one of the firms has something about it, basically it has a monopoly on some sort of a production technique, maybe from a patent or something like that makes it the lowest cost provider of that good. And it may be that, again, Volkswagen still might be doing a good job of managing their costs, but that GM is just, overall less costly because of some other reason. So efficiency is normally at a social level and accounting for the differences between firms or consumers and about that overall, how do we assign production and how do we assign consumption in society? And this is just a particular firm. So I know you're on the right page, and I probably said more than I needed to, but
that makes sense though. Yeah, I totally get you. Would you call efficiency related to like on a more macro level then rather than micro, or would that be a generalization?
Well, see, the thing is, when we talk about,
discuss that later if you don't.
Yeah, when we talk about micro and macro, and I can just sum this up really quickly because I don't think it's going to hurt anybody else. It's not like a waste of their time. Is that efficiency occurs in both macro and like microeconomic contexts, but microeconomics still is the domain of the industry as well as the firm. So the idea of like productive efficiency, like we're talking about among auto manufacturers, is a very sensible and properly considered microeconomic topic. For macroeconomics, so just because you have aggregates, like a collection of firms that make up an industry, it doesn't make it macro. What macroeconomics is really about is the interactions between industries and what we would call general equilibrium behavior. that doesn't really emerge until you don't just consider, like we could talk about, again, producing a car and producing it efficiently from a social perspective. Those are all proper microeconomic topics. But as soon as I say, well, does it make more sense for society as a whole to
even make cars?
Yeah, make cars, or what should be the optimal mix between public transportation and private transportation? Well, now you're starting to get closer to what macroeconomics is more about.
Right, I'm following you. Yeah, that makes complete sense.
Yeah, once you get industry interaction, then and to be honest with you, if it's a small number of closely related industries like I just talked about, between like cars and public transportation, a lot of times that is actually something that's talked about more by microeconomists than macroeconomists. But if you, again, like you were saying, like make it even bigger, like, if we start to include housing and what's the optimal mix of labor and capital for society between devoting labor and capital to housing versus transportation, well, then you're really pushing the boundary. Yeah, about like social resource allocation across everything. That's macro. Then you got there for sure. And there are a lot of these things that are, right on kind of like the boundary. And you'll see macroeconomists and microeconomists talk about them. But once you get at the most general level, the macroeconomists are there. And also I will point out at the very end that efficiency, in the way that we've been talking about it, gets really, really strained at the most macro level, because
too many pieces.
Yeah, which because like utility stops to have, for a consumer, we talk about distributional efficiency in terms of the goods, right? It's making sure consumers that value them the most are getting them. Well, at that level, it's really hard to talk about an aggregation of consumers that can, in the United States, it's 340 million people. We just got like too big.
Yeah, that's why we talk about utility and microeconomics and not macro.
Yeah, and they do actually use utility functions of what they call representative consumers. But like I said, the analogy gets strained. And normally what macroeconomists just do when they're talking about efficiency is they just talk about general measures like GDP per person and maximizing the amount of GDP per person. And it gets kind of, a little bit apart from what we're talking about. Anyway, okay. Thanks everybody. And I'm not signing off, even though I do have to go, but I'm going to stop recording.